Welcome, everyone, and thanks for joining our open webinar hosted by the MITx MicroMasters Program in Supply Chain Management. My name is Eva Ponce. I'm the Director of Online Education at MIT, the Center for Transportation and Logistics, and also the Director of the MIT Omnichannel Supply Chain Lab. Today, I'm honored to welcome our experts on artificial intelligence and e-commerce and e-fulfillment. I'm referring to Dr. Matthias Winkenbach, Director of Research at MIT CTL. Hi, Matthias. Thanks for joining us today.
Thanks for having me.
Excellent. And also Mr. Chris Huber, Manager at US Software for Mecalux. Chris, thank you for joining us today.
Very excited to be here.
Awesome. Thank you both. So this live event is brought to you by the MicroMasters Program in Supply Chain Management. I want to briefly introduce the program to you, and then we are going to deep dive directly in the discussion. So first of all, regarding the MicroMasters Program in Supply Chain Management, this is a professional and academic credential. It's 100% online. It's also global. We have learners from all over the world joining our program. And follow this asynchronous type of learning with a bunch of videos and practice problems and some homeworks just for you to learn at your own pace. One thing that is important to highlight from the program is that we provide MIT graduate level content. So what you are going to learn through this program is equivalent to MIT level, what we are teaching here on campus at MIT. And we follow a hands-on approach. It means that you will be applying what you are learning through the program across the different real-world scenarios, some real problems that we will provide through that. It is very comprehensive, includes 5 courses from supply chain analytics to supply chain fundamentals, supply chain design, dynamics, and technology and systems. If you want to learn more about the program, next week, Dr. Inma Borrella, the academic lead of the program, and Cara Grini, our academic program specialist, will be conducting an orientation webinar so you can learn more about the program. But let me start now engaging with you. We really want to learn more about you and the motivation why you are here. So please, let's try to launch the first poll. Let's try to see if you are here because you want to learn more about the topic, artificial intelligence in e-commerce and fulfillment. If you are interested in learning more about our wonderful panelists, Dr. Matthias Winkenbach and Chris Huber, or if maybe you are already part of our MicroMaster program and you don't miss any of our events. Let us know more about your motivation to be here today. In the meantime, what I'm going to do is just to briefly introduce the agenda. So for about the next minutes, we will learn more about our panelists, their background and their roles at the different organizations. We are going to also learn a lot about the role of artificial intelligence in e-commerce, and more specifically in e-fulfillment. We will deep dive in artificial intelligence solutions and applications to solve some of the key challenges in e-commerce, such as faster services or same-day deliveries, or just to try to gain more flexibility in this dynamic landscape. So you can also share your own questions with us using the Q&A feature that is provided via Zoom. So don't hesitate to bring your questions. Use this feature, please, the Q&A feature. And we will also share some polls through the event so you can engage with our panelists and with us through the event. So first of all, let's try to check our first poll. And let's try to better understand why our audience has joined today. Okay, so the most relevant question answer has been to learn about the role of AI in e-commerce, omnichannel, and e-fulfillment. So you are in the right place about that. 70% of you are here to learn more about the content, the topic, and also our panelists, which is great. So I believe that now is a great time to start introducing our panelists. So let's start with Dr. Matthias Winkenbach, Director of Research at CTL. So Matthias, tell us a little bit more of your background and also about your lab, more specifically the Intelligent Logistics System Lab that you have funded here at CTL.
Yes, sure. Thanks, Eva. And again, very excited to be here. Yeah, my name is Matthias Winkenbach. I, as many of us, wear multiple hats here at the center. One is being the Director of Research of the Center for Transportation and Logistics as a whole. But in this particular case, for this webinar, I think the relevant role is me being the Director of the Intelligent Logistics Systems Lab, which is a relatively new lab. We started it last year, roughly. And actually, Mecalux was one of our founding partners that made the foundation of this lab possible. And the reason why we started this lab is that throughout our work, and I've been doing this type of research for over a decade now, we've seen that machine learning and AI has become much more relevant than it used to be just a couple of years ago in solving problems in the supply chain logistics industry that are traditionally rather optimization focused or simulation focused problems. So nowadays, basically the state of the art on a methodological level is somewhere at the intersection between those traditional methods and machine learning. And that's kind of the sweet spot that we want to address with this lab, always tying it obviously to real world applications.
Excellent, Matthias. Definitely hands-on approach, always applying what you learn through the research. Thank you for the introduction, and thanks for being here today again. So now let's learn more about Chris Huber. So Chris, tell us a little bit more of your background.
Of course. I studied industrial engineering before starting my career in manufacturing and continuous improvement, and was there for some time. Eventually, I made the transition to supply chain software implementation for Manhattan Associates, where I worked for roughly 3.5 years. I started on the integration side and then moved more into the warehouse management systems implementation role. And then this wonderful opportunity came along to help Interlake Mecalux here in the US. I joined the software sales team and then worked for technical sales, both on automation and software side. And now we're really seeing the growth and love this partnership we have here with Matthias. But a little bit more about Mecalux as a whole is, and what kind of makes us unique, is our 3 divisions. So with our racking systems, automation and robotics, as well as software solutions, this allows us to really have some unique insight into the supply chain and the different items that we're seeing. But another thing that makes us a little unique is that we design, manufacture, implement, and support completely in-house. But of course, we do offload some research here with Matthias from time to time, and we're very excited.
Excellent, thank you. And also Mecalux is really an innovative company, and a company that is actively implementing this, the technology we are going to discuss today in real world applications. So thank you, Chris, for being here today. Okay, so let's start framing the problem. Let's start understanding the problem, and then we are going to deep dive more into some of these solutions and developments that you are both working on. So one of the key trends in supply chain management is the growth of e-commerce. Also, we need to bring here the rise in customer expectations. We know that approximately 70% of customers identify faster home delivery as their main expectations from retailers. And from a supply chain perspective, this trend introduces complexities, and these complexities are related to many different aspects. But one aspect I want to highlight is the omnichannel networks, and particularly the challenge that retailers are facing nowadays of integrating online and offline channels. So, Matthias, tell us more about this trend, more specifically the implications you are observing for supply chains, because we know this trend has truly transformed warehouses, and especially in the last decade. So I'm curious about hearing about your thoughts about how this trend is impacting supply chains.
Yeah, sure. I mean, you mentioned it, the complexities that come with this tremendous kind of increase in complex customer requirements are vast, and they span pretty much the entire supply chain. But if you focus on warehousing, just as an example, it's quite interesting to see how over the last, I'd say, 10 years or so, warehouses have really changed their role in supply chain networks and distribution networks. They've shifted from being just a simple big box to store stuff to become basically a complex fulfillment engine. I mean, if you think about, for instance, the inner workings of, let's say, an Amazon fulfillment center, this is so much more complex than what a traditional warehouse used to look like 10, 20 years ago. And there are a couple of key transformations, I think, that it boils down to. One is due to the nature of us now serving the end customer through multiple channels. For instance, picking operations have changed dramatically. We no longer do just batch picking for big box retailers who receive entire trucks or at least entire pallets of things. We're moving, or we have already moved, to single item, multi-channel fulfillment. So really individual picking for individual orders for individual customers or consumers. The other thing is, if you look at what's happening inside the warehouse, we have moved, or we are constantly moving from static warehouse layouts where the same thing gets stored in the same place every single day throughout the entire year to what we would call dynamic slotting. So becoming more smart and more dynamic in deciding when to put what where. And then just from a technology point of view, I think warehouses traditionally were heavily human operated. Now we see more and more integration of robotics technology, human-robot collaboration. That's also an area where Mecalux is probably one of the innovation leaders in the industry. And kind of the reason why this is happening is because we need speed. We need to become more proactive with these fulfillment operations that happen within a warehouse rather than reacting to basically when demand actually hits. So the key challenge here is to balance multiple objectives. One is we want to stay efficient, we want to keep costs low, but at the same time we want to increase speed, which means we need to move closer to the customer. We need a more fragmented network of facilities. We need higher levels of automation and analytics, and at the same time we want to stay sustainable. So these are objectives that are not necessarily aligned with each other, and that's where the real challenge lies, to align them to the extent possible.
Exactly. So the typical trade-offs in supply chain, but I would say elevated to the higher exponent because truly bring more complexity. Excellent. So also you mentioned the impact on redesign the supply chain networks. And we know also that this growth of e-commerce is impacting the network design, coming up with a more dynamic way to face these challenges. So from your perspective, Chris, can you share more about this specific impact, the redesign of the supply chain network? What have you observed in the industry?
Yeah, absolutely. And omnichannel fulfillment has been around in some form for a very long time, but obviously with the COVID-19 outbreak, it further accelerated the need for this transition for a lot of companies. So what we're seeing today and what this all means, from what Matthias hit on, is the centralized fulfillment model no longer works on its own when customers expect that next day or same day fulfillment. Even taking it one step further, which many people don't realize, is the returns process to support this e-commerce push is one of the most costly expenses in the supply chain, again, for these companies. And many of these retailers offer free returns. So to support this, retailers have been pushed to redesign their networks to bring inventory even closer to the customer and provide more points of access for returns. So in practice, this means adding more micro fulfillment centers outside of your city centers, and in some cases, even turning hybrid nodes that can fulfill both in-store purchases or online stores. You can see examples of this when you're online shopping and inventory availability or estimated delivery dates change based on the store location that you select, or when you're shopping in the store, they don't have your size and they'll ship to you for free because, again, that inventory is even closer. So blending these channels creates a lot of complexity, and suddenly you're asking that same inventory pool to serve walk-in customers, ship to home orders, buy online, pick up in store, and sometimes it's acting as that forward stocking location for B2B replenishment or sending to other customers. So to your question, the redesign we're observing just isn't about adding new infrastructure itself. It's making that entire network more dynamic, more data-driven, and flexible, so retailers can respond to those customer expectations without carrying significant excess costs.
Yeah, excellent points. Yes, more micro-fulfillment center. This is totally aligned what we are observing also in the omnichannel lab, working with big retailers, how they are developing these next generation fulfillment centers, micro-fulfillment center, just to meet these requirements from customers, speed, flexibility, and Matthias also brought the need of efficiency in terms of cost and sustainability goals that sometimes are not naturally aligned. So truly a challenge to manage that. Let's try to do the following thing now, because definitely we analyze the impact on the network design. Let's see now the role of AI. We know that AI companies are implementing AI for different purposes, but more specifically for this challenge that we are bringing here, and more specifically for this challenge of where to locate my inventory, where to position my inventory, from where to deliver the online order to my customer in order to meet their expectations about faster delivery, for example. How is AI playing a role here? We are going to deep dive more into this case. But before doing that, let's launch the second poll, because I really want to learn from our audience about, we know that some of our attendees today are supply chain management professionals. I'm curious about how are you currently engaging with AI tools in the context of e-commerce and e-fulfillment? Let us know if you are already applying some of the AI tools, if you are planning to apply, or simply, maybe you are not applying any of these AI tools. While you fill out the poll, Matthias, let's start with you, because we know that one of the key challenges in e-commerce is positioning the inventory across the network. Where to locate this inventory and from where to fulfill the orders are some of the key decisions that supply chain managers are facing today. We know also that your lab is working on using AI tools just to address this specific challenge. So tell us more about the challenge and more specifically the solution and the use of AI for that.
Yeah, I mean, first of all, why is this even such a complicated problem to solve? Because, I mean, we're basically trying to solve both a tactical problem that we face on the network level, so where to place the inventory, and an operational problem that we have more on an order level, namely where to fulfill that order from. So both this tactical and the operational problem is something that we try to ideally solve jointly in an integrated way, because they are actually highly interdependent. And those interdependencies are also not straightforward. They are actually relatively non-trivial, so hard to understand or hard to bake into some sort of a fixed decision rule that would tell us how to deal with that complexity. Because, for instance, depending on where you have historically allocated incoming orders to, that's a demand signal for a given fulfillment center or warehouse that is used locally to then decide, I mean, how much inventory of which product should I keep. But actually that decision where to allocate those orders to was previously influenced by another decision, which was where are we putting our inventory for which product in the first place. So you see how there's basically like a causal loop between those two problems. And that is something that is hard to resolve. Historically, companies basically solve those two problems independently. They typically first decide where to store which product, and then they decide where to allocate customer orders to and where to fulfill from. And that's fine, it works, but it introduces certain inefficiencies, because sometimes maybe it would be better to actually send an item from a further away distribution center, simply because that DC might be better positioned to fulfill that particular order, or might have all the items in that order, while the closest DC might not. So what's the promise of AI here? And we can't go in a lot of technical depth, but I see three main benefits of AI. One is to reduce uncertainty. So basically using AI and machine learning models to just come up with better short to medium-term demand forecasts and spatial temporal demand forecasts. So basically models that tell us, or at least indicate, who might be ordering what, when, not within the next month, but maybe within the next couple of days, or depending on how quickly you want to deliver to your customers, even within the next couple of hours. So that's something where traditional methods are just not that good, especially if we don't have a lot of time available to us. So first promise would be better spatial temporal demand forecasting. Second one would be to actually build models that can learn an integrated decision policy. So something that goes beyond just a static if then else type of rule, but that basically looks at both problems simultaneously and optimizes for both problems simultaneously. And tightly connected to that is kind of a third promise, which is building models that allow real-time dynamic fulfillment decisions. So basically not following a statically encoded rule that someone once came up with, but having a model that looks at the current state of the network as it is right now, like how utilized is it, how much inventory do we have, where and when, how many orders do we have in the system, all that stuff that's happening right now, potentially also looking slightly into the future, what are we expecting to happen within the next couple of hours or days, and then making a unique decision based on that state of the system on how to deal with an order that just came in. And that's something that traditional systems can't really do. Benefits are quite obviously lower cost, better inventory utilization, and therefore also better service to the customer.
I guess this also brings a lot of barriers, but before moving to the barriers, I want also to listen from Chris about which other additional benefits have you observed introducing these tools? Because definitely Matthias brought this real-time dynamic way to approach the problem, the integration in between different decisions that in the past were managed in a separate way. So what else are you observing as benefits for this solution, Chris?
Yeah, absolutely. So it's not only just the approach to solving the problem, but it's the actual way that it is being solved. And what that does is it allows you to move past your traditional forecasting methods into actionable decision making. And a very generalized approach to forecasting might look like, let's say for your procurement reorder points or maybe resource projection. You define your variables, you build your formula, you run your algorithm, and then measure your projected output versus the actual over the extended period of time. I mean, the key point here is that's very linear and it's quite static. So these variables such as what SKU should be selected, where they should be positioned, how much of each SKU, and to support what channels are extremely dynamic and often changing daily. And sometimes these companies are making decisions 2 to 3 times a day, so it can change by the hour. And when these companies use these predictive and prescriptive models, it then helps them to strike the balance across these channels dynamically. And those benefits are very tangible. And Matthias touched upon a lot of them, so I'll expand a little bit more, but those reduced delivery times. By pre-positioning inventory a little bit closer, we can also do that with respect to where it's most likely to occur. The lower transportation costs is something that's very tangible. Changing carriers sometimes, again, from the moment that order is dropped into the warehouse, sometimes changing 2 or 3 times by the time it actually makes it to its outbound dock. Avoiding excess safety stock. So away are the days that you can just put every SKU in every storefront or in every warehouse that has financial implications for the size of the warehouse or the amount of users needed to maintain it. And these are all driving costs for companies to make their decisions. But probably the most important is the gaining of resilience. So if any disruption were to happen, I had a customer one time say that they didn't ship for 2 days following the Super Bowl. So it's very dependent based upon that, and they can reroute these orders and make these decisions to make everything more robust.
Yeah. Thanks for bringing that point, because I know companies are very, very concerned about bringing more resilience into the supply chain. So definitely something that companies care a lot, and especially in this uncertainty environment that we have currently. I really see the value of providing these real-time fulfillment decisions, especially in today's dynamic environment in omnichannel. It's also great to see how these AI machine learning tools and models can learn an integrated policy for inventory placement and order allocation. Matthias, you brought that point that I think is really, really powerful in this environment, because it helps also to avoid these suboptimal decisions. And this is important thanks to the integration. But this is also difficult to achieve, correct? There are technical challenges, there are organizational challenges. We know data accuracy, data availability, system integration are kind of the top challenges that come to our minds. But I'm sure that Matthias, dealing with this project and working on the project directly, brought more technical and also organizational challenges. Can you elaborate more on that?
Yeah, sure. I mean, you touched upon a few of them already. So, for instance, data quality is probably one of the major challenges still, as surprising as that might sound. But even companies who have a lot of data from a lot of systems for many years realize once they embark on this journey that, oh, our data is actually not that consistent or not that interpretable, or actually we have a lot of data, but the one field that we would really like to have is not there. So data limitations are still a major challenge for these systems. The other thing is computational cost and complexity, because obviously you need to train these models somehow. And if you train large-scale models for real-world systems, that is relatively complex. So basically scaling these methods up to real-world deployments is possible, but not trivial. And then probably very importantly on the technical side is also the interpretability of a model. So people kind of have a hard time getting used to working with systems that are not human intuitively explainable, especially if things go wrong. It's easy to say what went wrong and look at the fixed decision rule and say, this is where we were wrong, or this is where we misspecified something. With machine learning models, it's not that easy anymore, because you might not be able to find the root cause of a decision that may not have been great. And that kind of also is a segue to the organizational barriers. I think probably the biggest challenge on an organizational level that we see is simple change management, kind of changing your mindset from being an organization that makes decisions based on fixed rules or at least intuition of very experienced people to being entirely data and model driven. And that is a question of trust to some extent. So people don't really know how AI works, and therefore they don't know whether they can trust its proposals. But it's also partially a skill question. So we do see in many industries that there's still kind of a missing profile of people who can bridge the gap between basically operational expertise, domain expertise, and methodological expertise. So people who understand both the business and the AI and machine learning models that are now basically penetrating that business. So that's in a nutshell what we see.
Yes, many different challenges. Change management, top number one for many companies, and also the need of new skills. We will talk more about that later through the webinar. Chris, before hearing from you about that, because I know you have been also dealing with some of these barriers, we have one question from our audience. It's from Wolfgang Hemmers. He's asking, because Matthias also brought the importance of data availability, but more importantly, data accuracy. Wolfgang is asking about what is the status of data quality and availability, especially in small and medium companies.
Yeah, so for that, I mean, it's before we start any implementation, one key question is how is your data integrity? Do you know where it lives? What kind of systems do you have in place to manage it? And for a surprising amount of companies, there's very little response that comes back from that. So it's something that is built into any implementation that we have. And we are working a lot with the small to medium-sized companies as well. So we can see and kind of help them through that migration. But through what we call our interface mapping sessions, where we talk about what that data field actually means for us, it helps them to clean up their data situation and become more in line, in hopes that when we go live, we've worked out 99% of the kinks, and the rest will kind of be cleaned up after that. So to answer your question, there's always room for improvement on that aspect. So I think on that space, there's some time to come.
Excellent. Thank you for bringing that, because truly this is the reality, and companies need to deal with that. So connecting again with the technical barriers, organizational barriers, what else have you been observing as a challenge for implementing AI tools in this area?
Yeah, the first one, and Matthias touched upon it, is the execution, bridging these cross-department teams. These are business units from store fulfillment to warehousing that typically haven't always worked together. So there's the aspect of not only learning the other business to learn how they're going to be integrated, but it's both directions. So it's not always downstream, and you're shipping from a warehouse to a store. But in order to really intertwine these two and make sure that you're operating in sync, you have to have full knowledge of both. So with that, we're seeing the teams expanding. Something that might be maybe 2 or 3 decision makers is now 5 or 6 on a call to make sure that we're fully considering all aspects. And one thing is the actual execution from, let's say, supply chain leaders down to warehouse managers, down to your storefront associates. These are decisions that once we implement AI, we make these decisions on the fly. We have to make sure that we're accounting for those end users all the way down to that last storefront. We've had customers that have spent months debating what a packing slip would look like and how it would arrive to the customer in what box. So these are decisions that are made at a very high level all the way down to the very end. So incorporating those two teams, top to bottom, is a huge challenge.
Excellent. Okay, so go.
The last thing I was going to add is from a system standpoint, these were developed very quickly. So sometimes they're operating in data silos. So if these data points aren't mapped appropriately from the store side to the warehouse side, you either have to map those concepts, understand that they maybe don't exist and create them, or integrate a new solution that's altogether conclusive of both of these processes.
Excellent. Yes. Integration at all levels is one of the key things companies need to overcome in order to implement that. So let's wrap up this case, the role of AI in inventory positioning and fulfillment. I think we can conclude that there is tons of potential of using AI tools in order to provide these real-time fulfillment decisions that Matthias was discussing at the very beginning. Very powerful also in integrating policy decisions for inventory placement and order allocation. Huge potential also to improve forecasting and demand forecasting also. Still some challenges to implement that related to data, system integration, skill gaps, change management, the new roles that we might need also to have in the companies. Let's try to share the results of the second poll, because I'm curious about how our audience are implementing this type of AI tools, if they are implementing. So let's see the result of the poll. Okay, so we have that 38% of our audience, and we have a big audience, almost 600 people joined today live. Thank you for joining us. Almost 40% of them are exploring options, but not implementing yet. 20% are piloting or testing AI solutions, and 14% are actively applying AI in multiple areas. And 10% are not using at all, or 17% is not applicable to their role. What do you think? Is this aligned with what you are observing, Chris, in the industry?
I would definitely say so. For customers and for AI chatbots appearing in Teams meetings and recording notes, that's something that a lot of customers are using today. So it's very much where it can see fit. Some things work, some things don't. So it's still very early, very exploratory, but it is absolutely happening.
Yeah, I would echo that. Like, in very easy to automate and kind of AI implement standard business processes like note taking, for instance. Sure, probably every company out there nowadays does this. But we just recently launched a survey actually together with Mecalux to kind of supply chain professionals looking at industry applications, and the results kind of mimicked partially what we saw in this poll here, that there is a lot of a majority of people still kind of feeling out where the real honeypot basically lies, like where the most fruitful applications might lie, which is partially driven, I think, by the fact that people don't have infinite amounts of resources to explore this new technology, so they need to be very selective as to what they try first.
Yeah, 100% agree. Let's deep dive now on another interesting case that also shows the use of AI in e-commerce and e-fulfillment. We are referring here to autonomous mobile robots. So, Chris, how is Mecalux leveraging AI and other advanced technologies, perhaps, to enhance these warehouse operations, more specifically using autonomous mobile robots?
Yeah, so we of course have those two projects in motion, changing from static rules into more dynamic rules that we just touched upon. However, we are also working with them on the routing of AMRs throughout the warehouse. And something that we're now seeing is the AMRs are replacing your conveyance runs more often. So moving from A to B, very simple tasks. And a fundamental principle when designing automated systems is to always build in redundancy for enhanced reliability. So keeping that in mind, it's very hard to ignore the fact that AMRs can be flexible with your throughputs that are either increasing or decreasing, or if one goes down, there's always another one to step into place. So with the growing demand on the AMR market, we've developed our own fleet of AMRs and are again looking for Matthias's team to support us and how we can improve that dynamic routing through the warehouse.
Yeah, and you touched one point that I also wanted to highlight is flexibility, because typically automation, the traditional automation is rigid. However, this type of solution brings the flexibility that, especially in the e-commerce environment, companies need. So that's a great point. Matthias, I know that you and your team are also developing algorithms to enhance and optimize the use of these AMRs in warehouses. I'm sure this is not a simple task at all. So could you share more with us about the approach and also the complexity associated to develop these type of solutions?
Sure. And maybe just for the part of the audience that may not be familiar with what an AMR is, there's various shapes and forms of these machines, but it's basically robots that move things from A to B within the warehouse, typically, whether it's pallets, boxes, racks. And they basically need to be controlled somehow. And that's where our project work basically starts looking into this subject. So we're not actually designing the hardware. We're not really looking into, for instance, computer vision or sensor analytics to help these machines to become better on the hardware side. But we are working on basically helping Mecalux innovate the software and the models that actually makes these machines smart. So basically helps these machines make better decisions. And this is basically a project that integrates multiple AI components that somehow have to work together. One is the actual routing and collision avoidance intelligence of those robots, basically, because as they move around, we obviously want to make them as flexible as possible so that they move around as naturally as possible, like a human would, and therefore use, for instance, the space within the warehouse as efficiently as possible, and therefore increase throughput, for example. But at the same time, we have to make sure it's safe so they don't bump into another robot or into a human or other things. So what we're doing here is we're, again, coming back to what I said in the very beginning, we're combining traditional methods with machine learning and AI. So actually, for the routing itself, we're using a vector field method. I'm not going to go into the details here, but that's a relatively efficient way of helping those robots to find a good path from A to B in the warehouse. And then we're adding kind of a convolutional neural network, so a machine learning, deep learning layer onto this that looks at potential collisions. So basically that predicts whether or not a robot might collide with another robot that might actually be on an intersecting path. And therefore that machine learning layer basically just corrects the routes of the various robots in the warehouse such that they don't crash into each other. The second component relates more to the question, which tasks should actually be picked up by which robot? So intelligent dispatching. So here we're using kind of a two-stage system with reinforcement learning, deciding when to release a task, so when to make it available for a robot to pick it up, and basically other neural network models to select then which AMR is the best suited to serve that task. And that may not always be the closest one because maybe the closest robot is almost out of battery and should rather go recharge. So this is a relatively complex decision to make. And then last but not least, we are having a memory system in place that tries to capture kind of the uncertainty within the warehouse, because sometimes someone might have forgotten a box in the middle of an aisle, or might have placed a pallet in the middle of an aisle, and the first robot detects it and sees, oh, there's an unexpected obstacle. The second one detects it, oh, there's an unexpected obstacle. So at some point, you want to create that kind of collective memory of there's something here that we don't have in our floor plan. So let's avoid this for the next couple of minutes to see whether someone might finally remove this obstacle, but to basically avoid running into the same inefficiency driver over and over again. The key innovation here, and that's actually very important, is that what we're trying to do is we're building a system that doesn't need warehouse-specific training. That's really important, even though it sounds simple. So the system we're building can be trained on, let's say, a few representative warehouse layouts with historical data, but then it can actually be deployed to any other warehouse environment that is within the expected parameters, which is very important for commercial deployment because training is expensive. So you want to have a system that you train once, and then you can actually deploy it across your entire network without expensive retraining for every single facility. Complexity, why is this such a difficult thing to do? Again, one complexity is scale. Just doing this for a single robot is maybe not that difficult, but doing it for a fleet of robots that move around dynamically is pretty hard, especially since many of these decisions have to be done in real time. Real time is another factor because of security. We can't wait for a model to take 20 seconds to make a decision how to take the next turn, because within those 20 seconds, the robot might have already met an obstacle. So that's something you don't want. You need really fast models. And then integration. Basically, it's not just about routing the robots. It's about how you handle orders within the warehouse, how you manage inventory, where do you place inventory, and how these robots actually interact with other humans or other machines in the warehouse. So that's kind of roughly why this is such a hard thing to do. We're just at the beginning of this, but making good progress so far.
Truly a complex problem. And I'm impressed about the collective memory. I love that part, definitely, just to help to learn also from what is happening, and the real-time component that you just mentioned. Definitely, this brings a lot of complexity here. Also, when we refer to these autonomous mobile robots, one important component is the collaborative part. I mean, these robots typically collaborate with humans. Sometimes we have a picker, and the robot comes to the picker just to help the picker to prepare the order. So there is some human-machine collaboration also in some of these examples. And Chris, I want you to expand a little bit more about this human-machine interaction and the common challenges you have observed when companies implement these type of solutions.
Yeah, to start, I honestly want to take it one step back, and one of the most important things is selecting the right application for the automation. There's so many different solutions. There's maybe 20 to 30 AMR vendors in the market. So with that, everyone wants the new and shiny piece, but that new and shiny toy, sorry, but that doesn't always mean it's the best fit solution for your application. So assuming you're selecting the right automation for your application, one big challenge is just underestimating the total commitment. Throughout the implementation, yes, we are applying our technology to your environment, but you are the experts on your warehouse, on your solution, on your business needs. So there's a full level of buy-in that we have to make sure that everything is as successful as possible. So there's maybe a little bit of underestimating the total commitment that's involved to apply this technology, but then also monitoring and maintenance going forward. And there's a little bit of, again, kind of a lack of understanding for, I think, Matthias, you touched upon this before, reporting of once we implement these AI solutions and this automation, you have to know how it's moving and behaving. While it is an extremely intelligent solution, you are still the owners of it. So you have to make sure that you are monitoring its progression and how it's moving in your warehouse. So that's something that honestly is sometimes a secondary thought through the implementation. But finally, and probably most importantly, is the overarching software architecture, is having a solution in place that is able to either meet the current demands of what automation you're trying to implement, but also future-proof for the various types of automation that are all playing together in that warehouse, from AMRs to picking lines to mini load systems to ASRSs. So all of these have to be aware of all the different humans and all the different automations playing together. So very important.
Excellent. So to wrap up this case, it's very clear for us, Matthias, that it's complex to implement a solution like that and optimize a solution based on autonomous mobile robots. It's also very important, and I want to highlight the point that Chris brought here. We need to understand the problem and then select the right solution and the right technology to solve that problem. And also to highlight how the flexibility that these solutions brings in a dynamic environment like e-commerce and e-fulfillment. You mentioned also, and we also discussed a bit about this human-machine interaction. Truly, this technology is also impacting people and the workforce. Recent research also shows that technology and automation is creating new roles, is redesigning existing ones, will likely lead to some roles to disappear in the warehouses. So I'm curious about to learn more, and I want to launch now the third poll about how these AI applications are impacting the workforce. So I have one question for our audience about which skills do you believe are most critical for future supply chain management professionals based on this discussion and the use of this type of technology? While they are filling out the poll, Chris, Matthias, what are your thoughts about this specific topic now? We are moving on this impact of AI applications, more specifically on the workforce and the redesigned roles, the need of new skill gaps, and so on.
Yeah, first and foremost is I suggest definitely sharpening your knowledge on analytics and data analysis. It goes into selecting the application, it goes into working with it on the day-to-day, and it's only going to continue to evolve from there. Next is going to be software solution architecture and the basics of integration. That's something that I luckily had very early in my career, but it's definitely helped step and kind of progress into this AI space. But luckily, a lot of the customers that are implementing automation have said exactly or supported exactly what you said, Eva. They're always looking to change roles and kind of replace and say, hey, we're going to take this a different route, but it's not necessarily replacing humans. So they're looking to leverage the current workforce that they have, and then again, just kind of teach and train how they're going to interact in the new environment. So while it can be a little daunting, the application of AI and robotics, it is very much still a very evolving state for how humans are going to play a role in that warehouse.
Yeah, 100% agree. Well, Matthias.
I would echo that. I mean, Chris touched upon some of the new skills that people probably need to develop if they don't already have them. And yeah, that basically resonates with our observations as well. Even though, let's say, the models that are out there become smarter and smarter, we still need people to be able to understand, at least on a sufficiently high level, how they work, how they arrive at their decisions, and therefore be able to kind of meaningfully challenge some of the model results, because not every model is always coming up with perfect solutions. Regarding the workforce, I mean, to be honest, sure, certain jobs will probably disappear because automation is becoming better, but that is honestly something that has happened many times throughout history, where technological innovation has made certain jobs obsolete and has created other jobs or different jobs on the other side. And especially if we're looking at warehousing, what comes to my mind is here at CTL, we have a relatively large research group that looks at longevity. So people actually getting older and being more productive for a longer period of time throughout their lifetime. But at the same time, if you have a 65-year-old warehouse worker, does he or she still want to lift heavy boxes and move stuff around? Or do they actually rather want to leverage the experience that they gained over the last 30, 40 years to do tasks that are harder to automate? And so I think it's probably also a technology that will allow us to keep people happy and productive in the workforce for a longer period of time. And so that's why I'm personally quite excited about it.
Yeah, definitely. Thank you both. Let's try to share the results of the poll and see what our audience think about that. So 64% vote for technological literacy, AI literacy. Yes, this is totally aligned with my most recent survey. And analytical skills. Yes, data analytics, analytical skills is something that definitely is a skill gap, and companies are demanding more and more. I want also to highlight here the importance of going to the fundamentals, to understand the core of the models in order to be able to challenge the solutions, in order to be able to understand the new tools. They are truly powerful, but we need to still have a good understanding of the foundations, what is behind the models. So it's not a black box for us. We can understand the solution. We can challenge that solution. So this is important. I'm going to ask for, do you have any advice? Because most of our audience are supply chain professionals. Some of them are MicroMasters learners that are pursuing for the certificate. Any advice that you can give to them before we wrap up?
Yeah, I think first and foremost is kind of don't be scared of adjacent fields. And I think it maybe speaks to people who are joining this call now. So hats off for that as a whole. But it's something that's helped me, is from software architecture to integration to automation to even AI. We can use AI to our advantage. So jump online and use that tool to gain as much knowledge about any adjacent fields that are around you, and that'll serve you very well, because you can be in many different conversations.
And my advice would be, both in life and in business, don't trust people who say they have a crystal ball. They usually don't. So, which kind of leads to Chris's earlier point, like, we need to learn the fundamentals to be able to have critical thinking and critical judgment of solutions that are offered to us. Like, all of us probably learned how to manually multiply and divide in school. We don't do it today anymore. We trust our pocket calculator. But if we had to, we could still challenge what the calculator or our Excel spreadsheet comes up with. And that's kind of the same skill set that people in our industry need. People don't necessarily need to be able to manually implement a deep neural network in their daily job, but they should be able to understand what the limitations of these systems are when they're facing a solution or a product that is powered by such a model. And I think that's a critical skill to obtain.
Excellent. Thank you both for a very insightful webinar. I really learned a lot about the two applications of AI in e-fulfillment. Thanks also for bringing the challenges. Thanks also for the advice to our audience. To my audience, I would say right now is a great time for all of you to join our global community of learners. If you want to learn more about these core models, the data analytics, supply chain key models, our supply chain analytics and supply chain fundamental course are open right now. You can also learn more about our program next week on September 9th at 11 a.m., where Dr. Imma Borrella and Cara Grini will be hosting an orientation webinar. I want to say thank you to my team, to Cara Grini and Elise Jonica, for supporting this event behind the scenes, answering many questions through the chat and the QA feature. And finally, thank you to our audience for joining us today. Keep an eye out for future events. Let's continue to grow and learn together in this exciting field of supply chain management. Thank you, everyone.